Good morning, everybody. My name is Ferhan Mazher, and today is 15th December 2020. The day is Tuesday, and right now I am at the 10th Cambridge class. The subject we are studying is Physics 5054, and we are studying the chapter of electrostatics. And this is the second lecture on this chapter. So today we are going to learn about a very interesting thing that is called electrostatic induction. And yesterday we have learned that if you have a metal, a piece of metal, a metal rod or a metal sphere, a piece of metal, and we know that the metals, they are solid, they are and they are conductor, they have free electrons in them. So those free electrons, they are not bound with one atom. They do not remain with a single atom. They do not remain with their only one and only nucleus. The free electrons are in the valence shells and they can move around in the body of the metal. So free electrons, you should understand this idea that that in this chapter and in the physics of your level, the protons are not given, the protons are not received, the protons do not move. What happens? Only the electrons are given, only the electrons are received. You see, and the metals, they have free electrons in them. And the free electrons are the electrons which move around in the metal. If the metal is this piece, from one end, they can go to the other end. From top, they can go to the bottom. From bottom, they are like floating in the metal. So they can move around in the metal. So those the free electrons. So metal has free electrons. So yesterday we learned that thing, that the metal, which is basically, it will be neutral. For example, if it's neutral, we took a piece of aluminum and it was neutral. The positive and the negative, they were balanced also. So you see, the recording has the there's a problem with the internet. Let's see what happens. So you see, because there is some problem with the internet and my PC, internet has gone. So it will be back in a minute. Yes, this happens daily. So join now. I will be presenting again. Let me present. This happens daily, that during our lesson, the internet is lost. Okay, so we were talking on this topic. Yeah. Now you see what happens. When you bring a charged body near a piece of metal, so for example, if I have a piece of metal, for example, and I bring a charged body near this end. So for example, this charged body is positive. If it is positive, all the free electrons in the piece of metal, they will be attracted to it. So the end which is near to this positively charged body, that will become negative, because all the electrons from all over the metal piece, free electrons, they are attracted to this side because of that positively charged body. So the end which is near to this charged body, that will become negative in the metal, and the other end will become positive. This is called electrostatic induction. That when you bring a charged body near a conductor, near a metal piece, what happens on that metal piece? The charges are created. One end becomes positive and the other one becomes negative. This is called electrostatic induction. Today we will learn a very good experiment, and it's a good technique also. It comes in MCQs, it comes in theory paper, and sometimes you have to make diagrams also. Sometimes the diagrams will be already there. You have to put the positive negative signs there. Now try to understand. This is an experiment in which we will learn how to charge two metal spheres. The metal spheres are basically neutral, and I want to charge them. I want to make them positively charged, or I want to make them negatively charged. You have to learn today the process how you do this, and it's not difficult. It's very simple. Okay, on your screen, the first diagram, the diagram A, we have two metal spheres, A and B. The first metal sphere, its name is A. The other metal sphere, its name is B. And they are standing on insulating stands. You see, the stands, they are insulating. Insulating means the electricity, they cannot flow through them. But these metal spheres, they are conductors. But the stands on which they are standing, they are insulating. And both the metal spheres, they are touching each other. They are in contact with each other. So, the metal sphere A, metal sphere B, touching each other, standing on two insulating stands. So that's the first diagram. And they are neutral. The balance of positive and negative all over the metal sphere is good. The positive and negative, they are equal, so the thing looks like neutral. Okay. So what you did, you took a positively charged strip. For example, you took a polythene rod and you charged it positively. So I have brought this strip which is positively charged near these two spheres. This is near sphere A. Okay, I have brought a positively charged sphere, a positively charged strip near sphere A. So because this is positively charged, what will happen? The electrons, the free electrons in those metal spheres, they will be attracted to this strip. So when they will be attracted, so what will happen? The free electrons, they will accumulate on this side, this left side of the sphere A. So you can see here the negatives have accumulated. So when the free electrons will move here on this end of the metal sphere A, so here excess electrons, more than the protons present there. So this end will look like negatively charged. And on the B, in the metal sphere B, you see on this end, because from here the free electrons have gone to that side, so here the balance is disturbed. So here the protons will be more than the electrons. Obviously the free electrons have gone to that side. So this side of the right side of the metal sphere B, that will become positive. And whenever we draw this diagram, remember one thing, one precaution we always take. If you have shown 4 negatives on the left side, so on the right side, you will show 4 positive. So equal amount of negative and positive. If you look at the metal sphere, both the metal spheres as a whole, they will be neutral because they have not basically lost electrons totally. Just the free electrons have gone to that side. Okay, so this side has become negative, this side has become positive. The reason is free electrons have moved to this side of the metal sphere A, and now there is a deficiency of free electrons in the metal sphere B. Now, by keeping this positively charged rod in its position, by keeping this metal charged rod in its position, I am saying, this should remain where it is. Slightly, slowly, move the metal spheres away from each other. But you will keep this positively charged strip or positively charged rod near them. And you move the metal sphere B away. So you broke the contact between the A and B. Okay. But when you are breaking this connection, this contact between the sphere A and sphere B, you will keep that positively charged rod near A. Okay. Once you have broken this contact, you have separated the A and the B, then you can remove the positively charged rod as well. Now, the positively charged rod you have put away. Now the metal sphere A and B are totally separate from each other. An interesting thing will happen. You will observe that all the free electrons which can move, they were on the sphere A, and the B was deficient in the sphere, free electrons. So now what you will observe, the negative charge will spread on A, the A will become negatively charged, and the sphere B will become positively charged. So, so this is how you charge sphere A and sphere B with the help of two spheres. They can be charged positively and negative. These are metal spheres, and this is the process by which we did this. Is the electrostatic induction. Okay, just listen to these wordings. Bring two metal sphere A and B and fix them on insulated stands, such that they touch each other as shown in the figure 13.5a. Now bring a positively charged rod near sphere A as shown in the figure 13.5b. Rod will attract negative charge towards it and repel positive charge away from it. Negative charge will appear on the left surface of the sphere A, which is close to the rod, while positive charge will appear on the right surface of the sphere B. Now separate the spheres while the rod is still near the sphere A. Now, if you test the two spheres, you will find that the two spheres will be positively charged, that the two spheres will be oppositely charged. Sorry, I said positively. Oppositely charged. After removing the rod, the charges are uniformly distributed over the surfaces of the spheres as shown in the figure 13.5d. You can see that. In this process, an equal and opposite charge appears on each sphere, I think. Hence, we define electrostatic induction as, in the presence of charged body. This is the definition of the electrostatic induction. In the presence of a charged body, an insulated conductor develops positive charge at one end and negative charge at the other end. This process is called electrostatic induction. Okay. I can show this in another book also. For example, this book. So here, the same experiment. Here we are doing the same experiment. And you can see here I have two metal spheres. They are touching each other. This metal sphere, its name is X. This metal sphere, its name is Y. This time I have a strip which is negatively charged. So what will happen when you bring a negatively charged strip near this metal sphere X? The electrons, they will be repelled. The electrons, the free electrons here, they will be repelled. So they will go on to the sphere Y. So on the left side of the sphere X, you see there will be a deficiency of electrons because the free electrons have gone to the right side of the sphere Y. Because of this negative matters from here, the free electrons are being repelled. So by keeping this negatively, look at this B diagram, by keeping this negatively charged strip here in the position near the X, what you do, you move the Y away. So you separate both the metal spheres. And once you have separated them, you have broken this contact, then remove this negatively charged strip. Once you have removed this, what you will observe that this X metal sphere, it has lost its electrons. its free electrons have gone to the Y, and the path is also broken. The contact is broken. So this X will become positively charged, and this Y will become negatively charged. So you see, in this, he says that this effect may be shown by bringing a negatively charged polythene strip. Let me, so you can also see what I'm reading. This electrostatic induction, we're talking about electrostatic induction. In this experiment, we brought a negatively charged strip. In the previous experiment, we brought a positively charged strip. So they serve the same purpose. This effect may be shown by bringing a negatively charged polythene strip near to an insulated metal sphere X, which is touching a similar sphere Y. Electrons in the spheres are repelled to the far side of the Y. If X and Y are separated with the charge strip still in position, X is left with the positive charge deficient, deficient of electrons, and Y with the negative charge, excess of electrons. The sign of the charges can be tested by removing the charge strip and taking X up to cap of a positively charged electroscope. This is how we test this. You don't need to bother about it because we will learn in the next lesson. Okay? So do you understand this story?
Yes, sir.
Hello? And can you tell me what you have learned?
Yes, sir. May I?
Yeah. Yes,
Sir,
please.
we will bring two conductor spheres, and we will attach both of them, and then we will bring a charged rod or a charged strip. It can be negatively charged or it can be positively charged. When if for example we have a negatively charged rod, and if we will bring it near one of the sphere, we will not take it in contact with the sphere, but we will keep it at a small distance. So when we will bring that negatively charged rod, all the all the protons will come on the left side, whereas all the
No,
electrons.
no, never say protons will come. Hello, 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 stop, stop, stop.
Ji sir.
In your discussion, in your description, never, never, never say protons came, protons went. No. Protons can go, electrons can come. You can only use the word electron. Yes. Again, yes.
Okay, sir. So all the electrons will move to the other side of the sphere Y, whereas, sir, then what will I say to the protons?
Nothing. The protons do not move.
Okay, sir. Then all the electrons will move to the other side,
They are inside the region. They are moving around.
whereas the side near to the electrically charged strip would become positively charged. Then slowly we will take the sphere X away. Sorry, then we will take the sphere Y away from sphere X by keeping the rod at its place, and then we will slowly take the rod away, and then we will find that the sphere X will be positively charged, whereas the sphere Y will be negatively charged.
Yes. Yeah. It's good. Okay, another very good example I can show you is if you have a single metal sphere. It is not shown here, like in both the books. In both the books, they have not given us that thing. But let me show you. Let me open the paint, and then I can show you another good example. Paint. Okay. Okay. So, for example, you have a single piece of metal. You have a single metal piece, and it is standing on an insulating stand. It's very important to tell that there is an insulating stand underneath. Okay.
Okay, okay, sir.
when you described at the start, you did not said that we have insulating stand. You only said that we have two metal spheres. So it's very important to say that we have insulating stand. Otherwise, that thing cannot happen. Okay. So now take a strip. It's a metal sphere. Suppose I take a piece of charged rod. It's negatively charged. Suppose it's negatively charged. So what will happen? The free electrons from the left side of this metal, they will be repelled. So they will go to this side. Okay. So here, let's say I am showing negative. So because from here the free electrons have gone, so this will be deficient of electrons, this side. So it will become positive. Try to understand this story also, okay? Now, when this is done, I brought this was neutral basically. This is a piece of metal, a sphere. It was basically neutral. And I brought a negatively charged rod near it, near the left hand. So the free electrons from here, they were repelled. So they went to the right end. So they accumulated here. So this end will look like negatively charged. And here deficiency of electron has been created. So this end will look like positively charged. Now, touch this side with your finger. This is the next step, okay? So now you will touch this side. Okay. You will touch this side with your finger. This is a funny hand, okay? Touch this end. When you will touch this end, because you are conductor and you touch the right end, so what will happen? The electrons through your body will go to the ground. When you will touch the right side of this sphere, the electrons through your body will go to the ground. Okay.
सर हमें शॉक लगेगा.
Yes, obviously. Light shock, yes. So these electrons here, through your finger, they have gone to the ground. Okay. Then, once this is done, during this whole process, that negatively charged strip should not go away. Once this is done, you will remove your hand also. Okay? Take your hand away. No more touching with no more path for electrons or charged particles to reach the ground. You touched it. The free electrons from here through your hand, through your body went to the ground. The extra free electrons which were accumulated have gone to the ground. And now you have broken the earth. You have removed your hand. This is called earth or ground. Grounding. Once this is done, then remove this also. Remove this negatively charged rod. Okay. Okay. You have removed this once, but the order is, first of all, you will break that grounding, that earth. You will remove your hand, which was touching. Okay. First, I broke this connection with the ground, your hand. I removed it. You are providing grounding. You are providing a path for the charged particles to reach the ground. Break that first. After breaking the earth wire or grounding or removing your hand away from the sphere, then you move that negatively charged thing also. Then if you look at the metal sphere has lost free electrons. They have gone to the ground. Now this metal sphere will become positively. And that positive charge will then appear throughout his body. The metal, this charge, then will appear on all the body, uniformly distributed. So this is how you can charge a single metal sphere. Do you understand this story?
Yes, sir.
And can you repeat what I just said? What did I tell you?
Sir, you told that again we will take a metal sphere and we will place it on an insulated stand, and
Yeah,
then we will bring um, a negatively charged strip
yeah,
near the near the sphere, and all the negative charges, all the electrons would move to the other side of the
yeah,
sphere, whereas the side near to the strip would become deficient in electrons,
yeah,
which means it will become positively charged. Then we will take our hand, we will place our hand on the side of the sphere which has more electrons, which is known as
yeah,
earthing. The electrons
yeah,
at that side will move to the ground through our hand, and it will use our body as its path. And then slowly we will take the strip away from the sphere, and then the positive, and then the side which is deficient in the electrons, then the whole sphere would become deficient in electrons. The whole sphere would become positively charged.
yeah. So these two stories are clear to you.
Yes, sir. The only thing difficult is to manage how to say, how to make a difference between electrons and protons, because protons never move and only electrons move.
Yeah, electrons are given and electrons are received. Okay. So I hope that you have understood this, and I hope that makes sense to you. It's very important. You see this topic, the two experiments which I just told you. From example, if you open your red spot or any past paper, you will find these questions on this topic, particularly these two. And the order is very important. The order means that, for example, in this experiment, that two metal spheres insulating on insulating stands, then you bring a charged rod near them, then you keep that charged rod there and you separate the spheres, and then you remove that charged rod. So this order is very important. And for example, in that when we charge the single sphere, so you have a single strand, you bring a charged rod near them, and then the end of the sphere, which is opposite to the charge rod, that at that end you touch it with your finger. Means you provide earth wire, you provide grounding, which means you provide a path for the charged particles to from the sphere to go to the ground, or from ground come to the sphere. So another I can say to you, for example, let me just came in my mind. I was working in the paint, you see, and for example, if I bring a positively charge, so what will happen? That's interesting, yeah. If I bring a positively charged metal strip near this metal sphere, so you see, because this is positive, the electrons will be attracted to this. So you see the negatives will appear here. They will be attracted to this positively charged strip. And this side will become what? Positive. Understand? Because from here the free electrons have gone to the other side. By keeping that positively charged in its place near the sphere, near the left side of the sphere, touch this side with your hand. Okay. So I am providing a path to the ground. Instead of moving the hand, which is quite difficult to draw the hand with the mouse. So I touch it with my hand. This wire means I am providing a path for the charges to come to the sphere or from sphere go to the ground. Both things can happen. So I touch it with my finger. So because it is positive here, the free electrons from the ground is a very big bank. It can give you electrons, it can receive electrons. So from the ground, the electrons will come here. From the ground, the electrons will come onto the sphere. And when the electrons will arrive here, they will neutralize this point. They will neutralize this. The free electrons, or you can say electrons, because this end was positive. When you connected it with the earth by touching it or with a wire, the electrons from the ground will come and they will neutralize this positive. But remember, the electrons came from the ground onto the sphere. Now, after some time, remove this metal strip. This charge sphere. Oh, sorry. First of all, you have to break this earth connection. Just break it. The first thing you need to do is break this earth connection. Okay? Once you are done with you have broken that, then remove this also. This charged strip, charged rod, just remove it. Okay? So there is no charged rod now. But you will observe this negative charge, it will spread. The whole metal sphere now will become negative. The reason is because it has now extra electrons which came on it from the ground. You see, in this both the experiments which are showing on your screen now, in the first experiment we were able to charge the metal sphere with positive charge, and this experiment we are able to charge it with the negative. So you see, I can charge the metal sphere positively, I can also charge it negatively, and the trick is kind of same. Okay? So now what you say? You understand? Hello?
Yes, sir.
Okay. So I think it's enough for today. We have learned two experiments in which we learned how to charge metal spheres. In this last experiment, we learned to charge a single sphere, and before that, the experiment we studied, in that experiment, we learned how to charge two metal spheres. So I hope that is helpful to you, and so please, you can also read it from your book. You have that physics labs and the same topics are there. You can read them from there also. So thank you very much and have a good day. God